A rigid tank contains 2 kilomoles of nitrogen and 6 kilomoles of carbon dioxide gases at 300 Kelvin and 15 megapascals. Estimate the volume of the tank. We can calculate this using compressibility factors and Amagat's law. Important values are shown in this table, as well as knowing that the ideal volume is 1.330 meters cubed. Pause the video and write these down. First, we need to find the compressibility factors for each of the individual components within the mixture, so that we can then find the compressibility factor of the mixture. We do this by finding the reduced pressure and temperature for nitrogen and carbon dioxide. Reduced temperature is equal to the temperature of the mixture over the critical temperature of the component. For nitrogen, this is 300 Kelvin over 126.2 Kelvin, which equals 2.38. Reduced pressure is equal to the pressure of the mixture over the critical pressure of the component. For nitrogen, this is 15 megapascals over 3.39 megapascals, which equals 4.42. We then take these values and look at them on a graph of compressibility factor against reduced pressure. First, find the value for reduced pressure along the bottom, then draw a line up to reach the line equal to the reduced temperature, and then draw along the graph to find the compressibility factor. Pause the video to do this. For nitrogen, you should get 1.02. Repeat these steps for carbon dioxide. The reduced temperature for carbon dioxide should be 300 Kelvin over 304.2 Kelvin, which equals 0.99, and the reduced pressure is 15 megapascals over 7.39 megapascals, which equals 2.03. These values on the graph should get a compressibility factor of 0.3. Next, we must find the value for the compressibility factor of the mixture. This is equal to the mole fraction of nitrogen multiplied by the compressibility factor of nitrogen, plus the mole fraction of carbon dioxide multiplied by the compressibility factor of carbon dioxide. This is 2 over 8 multiplied by 1.02. plus 6 over 8 multiplied by 0.3. This gets 0.48 as the compressibility factor of the mixture. Finally, to find the volume of the tank, we use the rearranged ideal gas formula, and we can substitute in the ideal volume to get the equation as. So the final calculation is 0.48 multiplied by 1.330, which equals 0.638. So the volume of the tank should be 0.638 meters cubed.